Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from October-November 2021, Paper 4, Variant 2. In this question, we will talk about the basic conditions required for simple harmonic motion. Means simply how we can classify a motion is a simple harmonic motion. Then we will talk about acceleration against displacement graph. And we will discuss how we can calculate time period if acceleration against displacement graph is given to us. Then we will talk about energy against displacement graph, and we will discuss where the kinetic energy is zero, where potential energy of an oscillator is maximum, and at what value of displacement kinetic energy and potential energy of an oscillator are equal. For question number 4, it is given to us a trolley on a smooth surface is attached by springs to fixed blocks as shown in figure 4.1. As you can see in this figure 4.1, there is one trolley that is attached by two springs. One spring is attached on one side of the trolley and the other spring is attached on the other side of the trolley. And each spring is attached with a fixed block. Fixed block simply means that this block cannot move. It will stay at rest. For this question, acceleration against displacement graph is also given to us. For part A, we need to describe the features of the line. In figure 4.2, features of the line, very important, that demonstrate that the motion of the trolley is simple harmonic motion. Now, first of all, let's try to understand conditions for simple harmonic motion. Means how we can say the motion of any object is simple harmonic motion. So we will discuss some basic conditions for simple harmonic motion. First condition is that acceleration has to be directly proportional to x. X is the displacement. Means when displacement is minimum, acceleration has to be minimum. When displacement is maximum, acceleration has to be maximum. Second condition is that A and X are in opposite directions. It simply means that when X is positive, A has to be negative. And when A is negative, X has to be positive, and vice versa. A and X are in opposite directions. And third condition is that A is directed. Means direction of acceleration is always towards equilibrium. Is directed towards equilibrium position. This is the third condition. Towards equilibrium. Is directed towards equilibrium position. So these are three basic conditions. We can also write down these conditions just in one equation. We can simply write down A is equal to minus omega square x. Means when x is maximum, A is maximum. When x is minimum, A is also minimum. When x is positive, A is negative. When x is negative, A is positive. You can also see from this graph. You can see when x is maximum, A is also maximum. And when x is 0, A is also 0. And when x is positive, you can see here, x is positive here, but A is negative here. So these are the basic conditions for simple harmonic motion. Let me explain you a little bit more about this one, and then we will write down our answer. The first thing we need to understand, when we say A is directly proportional to x, what will be the shape of the graph? If A is directly proportional to x, shape of the graph has to be straight line. So this is the first feature of the line, straight line. And when we say two quantities are in opposite directions, it simply means that gradient has to be negative. So we can say negative gradient. So here we can simply write down negative gradient. And these two features of the line, you can see this line is a straight line and the gradient of this line is negative. So it means the motion of this trolley is simple harmonic motion. And simply we have to write down these 2 points to get to marks. In your final answer, simply you can write down straight line through the origin. So this feature of the line tells us that A and X, they are directly proportional. And the second feature, negative gradient, it means A and X, they are in opposite directions. Means when one is positive, other is negative, and vice versa. And these are B marks, means they have to be in your answer. For part B, we need to use the figure 4.2 to determine the time period of the oscillations. If you look at figure figure 4.2. In figure 4.2, we have a graph between acceleration and displacement. We have already discussed for simple harmonic motion that A is equal to omega square x. Omega square x. And if we compare this one with straight line equation, y is equal to mx plus c. From here, you can simply see that gradient is equal to minus omega square. So simply we can write down here gradient in this case is equal to negative omega square, and c in this case is equal to 0 because it has no y-intercept. It is passing through origin, so c is equal to 0. Now simply we can find out the gradient of that, and that will be equal to omega square, or simply we can say omega square is equal to negative of gradient. So we can also write down like this, is equal to negative of gradient. Now simply we need to find the gradient. If we take 2 points on this line, let's say we take this point and we take this point. So this is our first point and this one is our second point. So we have to write down y2 minus y1 over x2 minus x1. Gradient is equal to y2 minus y1 over x2 minus x1. But omega square is equal to negative of gradient. So we have to multiply with negative sign here. Now simply we need to plug in values. So we can write down the coordinates of these points. Y coordinate is equal to negative 0.8, but x coordinate is 12 centimeters. So we have to convert this one into meters. So we can divide this one by 100 and we can write down 0.12. If we look at point 1, coordinates of point 1 are 0, 0. Now simply we need to plug in these values. So we have negative sign out and here we have negative 0.8 minus 0, and this is divided by 0.12 minus 0, and this is equal to omega square. Now if we simplify this, in this case you can see we have negative 0.8 and this is divided by 0.12. Simply we can say this is equal to 0.8 divided by 0.12, and this is value of omega square. We need omega, so we have to take square root on both sides. So we can write down 0.8 divided by 0.12 and the root of this. If we take root of this, omega will be equal to 2.58 radians per second, and this is value of omega. But question is asking us to find time period, value of time period. Now we need to understand the relationship between time period and omega. Time period is t, this is equal to 2 pi over omega, 2 pi over omega. Now we have value of omega. We can simply plug in value of 2 pi and omega. Omega is 2.58 radians per second. Now if we simplify this, we can find out value of time period. In this case, time period is equal to 2.4 seconds up to 2 SF. So this is our final answer. This question has 3 marks. The first mark you will get if you have written this relationship, you will get 1 mark. So this is C mark. Actually, this is also linked with this formula. If you have written these 2 formulae, you will get 1 C mark. And the second C mark you will get if you have got the right value of omega. And the last mark is answer mark. If you have got the right answer, you will get a mark. Part C1 on the line of the graph of figure 4.2, label with the letter P 1 point where the kinetic energy of the trolley is 0. So first thing we need to understand how we can calculate kinetic energy of the trolley. Kinetic energy of the trolley is simply equal to 1/2 mv square, and kinetic energy is equal to 0 if v is equal to 0. So simply we can write down here kinetic energy will be equal to 0 if v is equal to 0. Now we need to understand when v will be 0. V means the speed of the trolley. This is equal to plus minus omega times amplitude square minus x square. Speed will be equal to 0 means v will be equal to 0 if x is equal to a. So it simply means that speed is equal to 0 when displacement of the trolley is equal to amplitude. So a square minus x square is equal to 0. So simply in this case we can write down here displacement is maximum. So this is the point P. So you can mark point P here. You can also mark point P here because displacement here is also maximum. So if you mark here or you mark the point here, you will get 1 mark. This part has only 1 mark. For the second part, on the line of the graph of figure 4.2, we need to label with the letter capital Q an approximate position of one point where the kinetic energy of the trolley is equal to the potential energy stored in the spring. Question is asking us approximate position. We no need to calculate the exact one. Simply approximate position is acceptable. In order to answer this question, we need to understand the relationship between energy and displacement. So first of all, let's have a look at energy and displacement graph. In this case, you can see we have energy against displacement graph. Kinetic energy, the red line is the red curve. This is kinetic energy, and the blue one, this is potential energy, and green, this is the total energy. Question is asking us to find the displacement where kinetic energy is equal to potential energy. If you look at this point, this is halfway. So mean at this point kinetic energy is equal to potential energy. We need to find out the displacement. So this is the value of the displacement where kinetic energy is equal to potential energy, and this value we have to find out. Now if we divide this one into two parts, so this is about half of the amplitude, and the value where kinetic energy is equal to potential energy, this is halfway between half value and the maximum value. So it simply means that we have zero displacement here and we have the maximum displacement here, and the value of the maximum displacement is 12. So the approximate value of displacement when kinetic energy is equal to potential energy, that one has to be close to 8. So in this case we can mark this point. Actually this is the exact point. This is 8.4 centimeters, and this one we can also calculate. Now let's try to calculate this one. So simply you need to mark point Q here. If you mark point Q around 8, you will get 1 mark, and this has only 1 mark. Question is asking you approximate value. If you want to calculate exact position of Q, we need to understand kinetic energy is equal to 1/2 m omega square times a square minus x square. But potential energy at any displacement is simply equal to 1/2 m omega square times x square. Potential energy is equal to kinetic energy, so we can equate these two and we can find out value of displacement. Kinetic energy is equal to 1/2 m omega square times a square, we can say minus 1/2 m omega square times x square, and this is equal to 1/2 m omega square times x square. So we can cancel 1/2 m omega square. You can see these quantities can be cancelled. So from here we got a square. This is equal to 2 times x square. So from here we can find out a is equal to root of 2 times x, or we can say x in this case, this is equal to a divided by root of 2. A in this case, this is equal to 12.0 centimeters. If we divide this one by root of 2, we can find out exact value of x, that will be equal to 8.4 centimeters. So this is how you can find the exact value. Question is asking you only approximate value. So if you mark around 8, you will get 1 mark for this question. But this is how you can also calculate exact value of x.